Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.89. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is always equal to the product of current through this resistance and the value of resistance itself. Now move towards the problem. Exercise problem number 2.89. Find the value of voltage Vs in given below figure if voltage V0 is equal to 4 volt. This is the circuit diagram of given problem. Inside this network, we have to find the value of voltage across this voltage source labeled as Vs. While the one condition that is given, voltage across this 1 kilo ohm resistance is 4 volt, that is labeled as V0. So without wasting time, let's proceed towards the solution. First of all, we will try to find out current through this 1 kilo ohm resistance because voltage across this resistance is given. Current through it will be equal to voltage divided by the value of resistance. Voltage across this resistance is 4 volt and the value of resistance is 1 kilo ohm. So the value of current will be 4 milliampere. Now the direction of current will be clockwise direction because in order to make this point positive, the current should be enter from this terminal and leave from this terminal. And because of series connection, this same current will be flowing from this 2 kilo ohm resistance as well. So we can calculate voltage across this 2 kilo ohm resistance because current through it is calculated in previous step. Voltage of this 2 kilo ohm resistance will be the product of 4 milliampere and the value of resistance 2 kilo ohm. It will become 8 volt. So 8 volt will be appearing across this 2 kilo ohm resistance, and because the polarity of current through this 2 kilo ohm resistance is clockwise direction, so positive terminal will be here and negative terminal will be here. Now 4 milliampere current is leaving from this node while 2 milliampere current is entering on this node. So in order to leave 4 milliampere current from this node, current of this branch should be entered to this node and the value of current will be sum of both entering currents minus leaving current. So it will become 2 milliampere. So 2 milliampere current will be entering to this node in order to leave 4 milliampere current from this node. Because of series connection, this same current will be flowing from this 3 kilo ohm resistance as well. So we can calculate voltage across this 3 kilo ohm resistance, that will be the product of 2 milliampere and 3 kilo ohm. It will become 6 volt. And the polarity notation across this 3 kilo ohm resistance will be positive terminal here and negative terminal here. Because the current is entering towards this node, it means the direction of current is clockwise direction. Modify the network by indicating voltage across this 3 kilo ohm resistance. Voltage across this constant current source will be equal to the sum of voltage across these two resistances. Now apply Kirchoff's voltage law inside this closed loop to calculate voltage across this 12 kilo ohm resistance. KVL equation for this closed loop will be, start from here, current entering terminal is positive, so 6 volt will be taken with positive sign. Next is 3 kilo ohm resistance, current entering terminal is positive, so voltage across this resistance, that is 6 volt, will be taken with positive sign. Next is constant current source, current entering terminal is positive, so 12 volt will be taken with positive sign. And at the end, current entering terminal is positive, so voltage across this 12 kilo ohm resistance will be positive. Now add these values together, their sum will be 24 and place it on the other hand side of equal to calculate voltage across 12 kilo ohm resistance, that will be minus 24 volt. This minus sign along with the value of voltage across 12 kilo ohm resistance is indicating that the polarity notation across this resistance is wrong. Actual polarity notation is positive terminal here and negative terminal here. So modify the circuit by indicating actual polarity notation across this 12 kilo ohm resistance. Now we have the value of voltage across this 12 kilo ohm resistance. We can calculate current through it. That will be equal to 24 volt divided by 12 kilo ohm. It will become 2 milliampere and the direction of current will be downward, entering from positive terminal and leaving from negative terminal. Now we will apply Kirchoff's current law on this node to calculate the current of this branch. For that purpose, we will assume current I is flowing through this branch, and this current will be equal to the sum of these both currents because both currents are leaving from this node and only I current is entering towards this node. So the equation for current I will be equal to sum of both 2 milliampere currents. It will become 4 milliampere. So 4 milliampere current will be flowing through this branch, and the direction of current will be clockwise direction because this current is entering towards this node. Now we can calculate value of voltage across this 3 kilo ohm resistance because current through it is calculated. So voltage across this 3 kilo ohm resistance will be the product of 4 milliampere and 3 kilo ohm. It will become 12 volt. Modify the network by indicating voltage across this 3 kilo ohm resistance with their polarity. Because the direction of current was clockwise direction, so current entering terminal is taken with positive sign and current leaving terminal is taken with negative sign. Now we will apply Kirchoff's voltage law inside this closed loop to calculate voltage Vs. For that purpose, we will start from here. Current entering terminal is positive, so 12 volt will be taken with positive sign. Next, Vs will be taken with negative sign because current entering terminal is negative. And voltage across this 12 kilo ohm resistance will be taken with positive sign because current entering terminal is positive. Solve this equation. Add 24 volt and 12 volt together, it will become 36 volt, and place minus Vs on the other hand side of equal to calculate its value. That will become 36 volt. So the value of voltage Vs inside this network is 36 volt. This was exercise problem number 2.89. Thank you. See you again in next video.